What's up? I've got another review video. So today was just a review day. I looked more into TCP and also just into packets in general. So in the last video, I showed the very minimal working example I had of the TCP server that I was implementing with a socket and how I was able to open it up, listen for incoming connections, and read the data being sent by clients that were attempting to connect with that TCP server. And so what I was working on was having a script on the same machine ping that port with data and then have the server read out that data as it receives it. The next step that I want to work on tomorrow is figuring out whatever issue with Windows Firewall was preventing me from doing the same thing on my laptop, and then sending some packets, sending some connection over from my laptop and verify that it's being received by the TCP server that I'm running on my desktop. Besides that though, today I mainly looked at two things. I looked at TCP and packets. So for TCP, I just wanted to get a general idea of how it works. Still can't remember exactly what it's called. It's transmission something protocol. I want to say transmission control protocol. Let me look this up to see. Transmission control protocol. Okay, that's what I thought. And I keep getting tempted to say TCP protocol, but the protocol is already in the third letter of that acronym, and so I'm going to stop trying to say that. But I read about two things. I read about the connection sequence and the disconnection sequence. So I'm just going to summarize what I read over and what I've taken notes on and reviewed so far. So when you have two hosts and they want to initiate they want to initiate a TCP connection with one another, the first one sends a synchronized packet to, I'll call them the client and the server for this purpose. So the client, which wants to initialize the TCP connection, will send a synchronized packet to the server, which is basically just saying that it wants to request a connection between those two hosts. The server will then, if it chooses to engage with that client, it will send back a synchronized acknowledge packet, which is saying that it saw the synchronized packet and it's acknowledging that it's willing to establish a connection. And then finally, the client, the initial host which first sent the synchronized packet, sends back another acknowledge packet that says, I acknowledge your acknowledgement, and the connection's established and we're ready to start transferring data to one another. So once that window is open, they can send data to each other until one of them decides they want to close the connection and stop sending data. However, one host could decide that it wants to close the connection at a certain point, and the other host still has data that it has to send over. And so to avoid data getting lost and the connection closing prematurely before all the data is sent between the two hosts, there's another procedure that I learned about. So this is the procedure of severing the connection. And so the first thing that happens is that the host which wants to terminate the connection is going to send a new packet to the other host. So in this case, to differentiate them, I'll say the host that wants to end the connection is the sender, and the host that is receiving that request is the receiver. So the sender says that it wants to terminate the connection. It sends a fin packet, which is, I assume that stands for finish. They want to finish the connection. Similarly to the initial procedure of establishing the connection, the receiver sees that fin packet sent to it and says, okay, I'll send back an acknowledge packet that says, I'm acknowledging that you want to initiate the end of this connection. And then when the sender receives the acknowledge packet from the receiver, that's how it knows that they're about to stop the connection. However, the receiver is going to keep sending data to the sender until it's done with whatever segment of data it's sent. So if it's sending a file, it might receive the fin packet, send back an acknowledge packet, and then keep sending the rest of the packets associated with that file that it's transferring. And then upon the completion of that task, then it sends back its own fin packet. So how it starts is one host, the sender, sends a finished packet. The receiver receives it, acknowledges it, finishes sending the rest of its data, and then sends back a FIN packet. So now both hosts have received FIN packets. And then finally, when the initial sender receives the FIN packet from the receiver, it knows that the receiver is done sending data, it's ready to end the connection. And so the sender will send a final acknowledged packet to the receiver, and then the connection is terminated. And so this makes a lot of sense, and I think it's good for me to learn about this, because even though I'm probably never going to interact with networks or anything like that on such an intimate level where I need to be writing software that is implementing this or has to take this into account, I think it's good to just understand how these things work under the hood, because if I'm ever working with some sort of endpoint over TCP and something fails or data gets lost or any of these things happen, I know this is how the connection is supposed to have been established and this is how the connection is supposed to have ended. And so if something abnormal happens, I know the way things are supposed to work and how it's supposed to look. And I think that's the real advantage of knowing how these protocols work, is when things go wrong, you know how the protocol is supposed to be functioning. And so you're able to look at whatever error transpired and compare it to how things are supposed to have gone. And you can say, oh, okay, this stage failed or something went wrong here. The other thing that I looked into and took some notes on and reviewed was packets. So obviously I've got a general fuzzy idea of what packets are and what they're used for. Before I did any reading, I generally understood that packets were just groups of information that are sent from one host to another along a connection, and that usually if you've got a lot of data being sent, you will be sending more than one packet. You'll send multiple packets. And I also am familiar with packets because in video games, if you're lagging, oftentimes it'll say that you're getting packet loss, and that's the reason why your connection to the server that you're playing on is unstable. But what I wanted to do is I wanted to actually get an idea of what do packets look like and what sort of information is within them. So, I mean, obviously at the end of the day, it's just a bunch of bytes, just a bunch of binary information. But what I was interested in is how are those bytes arranged? What's the format that actually makes the content of the packet legible to everybody? So from what I read and what I took notes on, I see that there are three main parts of a packet usually. And I think there can be more parts, but these are the three like core parts that you're going to see in every packet. So you've got a header, and then after that you have the payload, and then you have a footer. And so the header contains a lot of metadata about the packet. It doesn't have data itself, or it does have data, but it's metadata about the actual data being sent. So the header would have things like the source IP, where the packet's originating from, and the destination IP, where it's going to. It might have the protocol that the packet is being sent through, and it might have it's not that it might, it will. When something like a file is split up into a bunch of packets, they aren't sent sequentially, they're sent out all over the place. And so if they're arriving in a different order from what they were sent out, that means that they have to be rearranged in a particular order. And so that means that within the metadata of each packet, you need to have a number which indicates the number in the sequence that that packet occupies. So if you send out 10 packets and they don't arrive in the order 1 through 10, you can look at the metadata, see what number they are in the sequence, and then rearrange them into the way that they're supposed to so that you're getting the data in the right order, or at least that's how I understand it. I'm not sure if individual units, like let's say if you're sending a file or you're sending a base 64 string or you're sending a bunch of stuff, I don't know if the sequence number for those packets is only for that unit of information you're sending, or if you send like 10 images, does the sequence number of that packet just keep counting up, or does it start from 0 for each isolated unit of information you're trying to send over a connection? I'm not sure. I'll probably have to look into that. But regardless, it's for rearranging stuff in the right order on the server side. And then additionally, if you guys ever took any sort of fundamental CS class, like I took digital logic circuits and things like that, you'll know that error correcting is a big deal. And so the header will also contain metadata for error correcting to make sure that if there was a bit flip or if information was somehow corrupted, we're able to verify that that happened. And I suppose you'd request a new packet because it's been a while since I've thought about error correcting codes, but I think maybe sometimes you can figure out which bits flipped or corrupted and then reset them back to what they should be. But I think after a certain point, if it's really messed up, you probably just need to request a new packet. Regardless though, that's the main content of the header section of the packet. Then you have the payload, which is just the raw bytes representation of whatever you're sending, whether it's an image. Well, I guess if it's an image, it's probably already in base64 format or some sort of format, but whether it's text, an image, or I suppose even if it's an HTTP query, whatever you're sending, the payload of the packet is just a bunch of bytes. And once those bytes are put in the order of all of the packets in which they were sent, you're able to reconstruct the overall object that you're trying to send from one host to another. And then finally, you have the trailer, which has error detection information. I'm not sure if it's the same error detection information that can be in the header. It might be that those two sets of information go together to enact an error detection routine on that particular packet. But generally, packets are good if you've got a big item of data and you want to split it up into multiple smaller units to be efficiently sent over a network. But yeah, that's what I've worked on today, just doing some reading and some reviewing and some note taking. Tomorrow, I want to go deeper on the TCP WebSocket, or the TCP server and the socket underneath it. So I want to be able to send and receive data from a separate machine. So I want to be able to send data from my laptop, receive it on the desktop or on the TCP server, and then send data from the TCP server on the desktop back to the laptop. Once I've got that established and things are working on that front, then I can start writing code for the TCP server to handle the HTTP protocol. And then at that point, I could start pinging the TCP server with something like the requests library from Python. And if my server can handle that and then send back coherent responses, at that point, I suppose at that point I've made a rudimentary HTTP server, and then I can start looking into ways to expand that project, maybe do some more advanced network interfacing stuff. But yeah, that's the plan for now. Been doing some research for what I need for the HTTP server project, and I'm going to work on making some more progress on the coding aspect of that tomorrow. That's all. Have a good one.